Okay then guys, let's have a little look at this paper before we go through it question by question. This is a C4 January 2011 examination paper for the AQA examination board. Basically, it's a good idea and good practice to look through an exam paper before you go into an exam at the beginning of the examination at the outset. It stands you in good stead for the entire 90 minutes duration, and because you can then choose what questions you want to do, but also you familiarise yourself with the entire content of the paper. So with those thoughts in mind then, let's have a quick look at this paper, see if there's any stinkers. We'll see if there's any questions we might think are easy that we can do at the beginning. Trig stuff, compound angles, this is fairly standard. Maximum value will be easy to obtain then, and find when this maximum value occurs is just solving this equals a value. So that's a standard question, no surprises really, and a nice question to start with, and it is question 1 anyways. So the next question now, polynomial, cubic, factor theorem, that's easy. Then we need to do division of some sort or equate powers to work out the other factors, and then we need to simplify this, a little bit of jiggery pokery here, and then we've got this problem here. This should be easy, this second part, shouldn't it? Divided by this, use the remainder theorem. We know the remainder is minus 4, it says. So then we can find the constant p. So that question 2 is quite nice, might be a couple of little snags, but nothing of any major concern there. But seems like a reasonably long question, fair bit of work to do there. Question 3 now. Let's have a look at this. Partial fractions, easy. Then when you've got that, you can use the binomial theorem to expand it up to x squared, fairly standard, and the range of values where this is valid. It looks more worse than it is. It's a nice easy question to do. So that's a good one. That's question 3 done then. Question 4. Let's have a look at that one. So parametric equations, differentiation, do y dx, get the gradient when t is 0, tangent as well, and then the Cartesian equation, just rearranging into a Cartesian form. So that's a lovely question. That is question 4. Nice easy question to do. Shouldn't take an awfully long time to do. So the next one now is 5. We've got a model of a radioactive decay is here. Initially mass m0. So input some values, get your answer. m over 16, put that there. Work out what the time is in days. And find the value. And then less than 1% of its initial mass. So that would mean, reading that correctly, it's decayed to less than 1% of its initial mass. So put in 1% of its initial mass. So m0 over 100 would go in here and solve for t. And then you'd be able to reason on what the minimum integer value n is required there. So again, it's not too problematic, that question, but you've got to be careful to understand what it says. Oops. So next question now is this one, which I scooted past, number 6. Trig stuff, double angle. Show that we've got these solutions, doesn't need double checking when you have a question like this. Then solve, and then solve this equation, which is a different arrangement. Again, show that this is the case, and then find the solutions are given by this. So question 6 doesn't really need double checking if we get time at the end of the examination. Nice trig question there though, isn't it? 7, differential equation, separate the variables and integrate. Show you get this solution, doesn't need double checking again. The heights, we're given this equation, which is what we've got above. And then we work out, once we've got the solution here, probably minimum and maximum heights, or when these occur, or when is it 5 meters above the ground. So that's a nice question, fairly user friendly again, so that's alright. Next question is number 8, which is the last question in the paper. A and B, line, vector AB is okay, that'll be fine. Acute angle between these two things. When you do the dot product, you might get the obtuse angle, you just got to take 180 away from it to get the associated acute angle. D lies on L1, well M does 2, L2 passes through D in parallel to AB. Find the equation of L2 with parameter mu. And then you've got this problem here. This is not a nice problem here. This is when I work through it. So they're a pretty horrendous problem actually. It takes a long time to do. So you might be better off double checking sometimes all your work to make sure you do that before you actually try and do this part of the problem to get some final marks. But you pay your money, you take your choice, isn't it? But personally, I think this question here is a bit of a stinker, and so all the best when you get to have a go at it in the worksheet itself. So the paper overall then, the first few questions, all of them bar the last one, seem fairly okay, and just remains for me to wish you well if you've got a C4 exam in the near future, guys. All the best with it. I hope it goes well. Hope you work hard, prepare well, and get the marks that you deserve for the examination. So all the best then, guys, and hopefully I'll catch you again in another live worksheet. Cheers!